So yesterday you investigated the end behavior of polynomial functions, and hopefully you saw the relationship between the degree of the polynomial and what the end behavior does. In the other video I just posted this morning, we looked at how we can describe the end behavior in terms of how when x goes off to negative infinity, what happens to y, and when x goes off to positive infinity, what happens to y, or the output of our function. So describing our end behavior in those terms. So just to recap, end behavior based on the degree, let's look at a few examples. So uh, here I have a quadratic, x squared minus 2x minus 1, and this has a degree of 2. Our a is positive. So we have on the left-hand side, if we're moving from left to right, we have up, and on the right-hand side, we have up. So we would describe the end behavior as up and up. Um, so notice what happens when we change the sign of a. So if I make it a negative x squared, um, it flips or reflects our parabola across the x-axis. So now it goes the other direction. Now our end behavior is down and down. Um, so you can see that when the leading coefficient is negative, the end behavior is going to be the opposite of what it is if it's positive. So let's look at a third degree function. If we look at this, our leading coefficient is positive, so our a term is positive here. We have a cubic function. This is a third degree function, and the end behavior is down on the left and up on the right. So we would say this is down and then up. Again, watch what happens when we change the sign of the leading coefficient. Now our end behavior is up on the left-hand side and down on the right-hand side. So it's the opposite of what we would initially expect from a third degree polynomial. So moving on to fourth degree polynomials, we can see that the end behavior is up and up, similar to what it was in a second degree polynomials. And hopefully you concluded yesterday that even degree polynomials will have an up and up behavior if a is positive. And again, if we make this negative, we might have to scroll down some, but we can see that it appears that we are going down and down. So it changed the direction, the sign of the leading coefficient changed the direction of our end behavior. And then finally, we'll look at a fifth degree function. And again, we should have concluded yesterday that odd functions would be down and then up. Okay, just like our third degree one, if we put that one back out there. So down and then up. And again, if we change the sign on this, it's going to flip. If you'll just notice what that does, that changes. So instead of down and then up, it's up and then down. So making the leading coefficient, or the a term, negative changes the direction of your end behavior. But to summarize, even degree polynomials should have up and up behavior if a is positive, and if a is negative, they will have down and down behavior. And odd number polynomials, if a is positive, will have down and up behavior. And if a is negative, it will have up and down behavior. There's a chart in your book that summarizes all this information, and that will be posted in the Google Doc as well. I will paste that chart in there, but that would be a handy thing to have close to you as you're doing these problems as a reference to kind of remember what the end behavior of these particular functions do. So now we're going to look at some examples on Khan Academy. So we're given the polynomial function h of x is equal to negative 2x to the fifth plus 8x to the fourth minus 2x squared plus 15. To determine the end behavior of our polynomial, we need to examine the degree of the polynomial. This is already in standard form, so we know our first term should indicate the degree of the polynomial. So this is a fifth degree polynomial, which means it's an odd polynomial. And we saw that odd degree polynomials, the end behavior is down on the left. So from left to right, it's down and then up. The other thing we need to look at is the sign of the leading term. So since this is negative, it means our end behavior is going to go the opposite direction. So moving from left to right, this function is going to go up. The end behavior is going to be up and then down. So what that means is, if we look at our choices, we're given some choices here. As x goes off to infinity, h of x, or our output, goes off to infinity, okay? So what that means is that as x gets bigger, y is getting bigger. So that indicates an up behavior, okay? That means that graph is heading in the upward direction on the right-hand side. So we know that can't be one of our choices because we know that it should go down on the right-hand side. So let's look at the next choice. As x goes off to infinity, so as x gets bigger, h of x, our output, gets smaller, okay? Heads off to negative infinity. So that's a possibility. Our behavior should be up and then down. So this indicates that the graph is going down on the right-hand side. And then as x goes off to negative infinity, so as x is getting smaller, h of x, the output, is getting larger. So that indicates up. So on the left-hand side, this is saying that the graph is going up. And that's what we want. We said it was up on the left-hand side and down on the right-hand side. So this is our logical choice. Now, let's look at another example. So we're given some graphs here to examine. So we want to look at the polynomial function h of x equals 9x to the fifth minus 12x to the third plus 6x. Again, we're in standard form. So this is a fifth degree polynomial. So it has an odd degree. So our behavior should be down and then up. So let's look at our choices. And this does say select all that apply. So there could be multiple representations that could have the same end behavior because you're not selecting the graph of the function. You're just choosing functions that have the same end behavior. Okay, so down and then up. So this would exhibit the same end behavior. Even though this is a linear function and we know that this is not linear, we're just asked to show which functions have the same end behavior. So graph B also is down and then up. So that has the same end behavior. Graph C is up and then down. So that is not the same end behavior. And graph D is up and then up. So A and B are the two choices that match the same end behavior as our given function. Let's take a look at another example of describing the end behavior of the function. Again, we're going to look at the first term because this is in standard form. So this is a 6th degree polynomial, which means it's an even degree polynomial. So our end behavior should be up and up. But the sign on our leading coefficient is negative. So we know our end behavior should be the opposite of that. So it should be down and down. This this should open down, just like when we looked at quadratics, having a negative coefficient out here meant that the parabola opened downward. So the same thing applies here. So we should have a down and down end behavior. And what that means is x goes off to negative infinity, h of x goes off to negative infinity. And as x goes off to positive infinity, h of x should also go off to negative infinity as well. So both of our outputs should be heading towards negative infinity as x gets larger and smaller. So let's look at our choices. As x goes off to positive infinity, h of x goes off to positive infinity. We know we can eliminate that because that indicates up behavior. As x goes off to as x goes off to positive infinity, h of x goes off to negative infinity. Okay, so that's a possibility. And as x goes off to negative infinity, h of x goes off to positive infinity. Okay, that indicates up behavior, and we know we should have down and down. So choice 2 is out. As x goes off to positive infinity, h of x goes off to negative infinity. That's down behavior. And as x goes off to negative infinity, h of x goes off to negative infinity. That is also down behavior. So that is down, and that is our correct answer. Okay, again, looking at this function, let's look at the degree. We have an even degree, but it's negative. Okay, even degree means should say that we have up and up, but since it's negative, we should have down and down. Okay, so this is very similar to the last one we have. So as x gets bigger, as x goes off to positive infinity, p of x is getting smaller. Okay, so that's down, and as x goes off to negative infinity, p of x is also going off to negative infinity. That's down as well. So this should be the same choice as before. Now, we have a odd degree polynomial. So our behavior should be down and then up. And this is positive. Okay, our leading coefficient is positive. So our behavior remains the same. It should be down and then up. So down, moving from left to right, down and up means that as x goes off to negative infinity, okay, h of x should be going off to negative infinity. That's down behavior. And then as x goes off to positive infinity, we want h of x to go off to positive infinity. So that's going to be this choice here. As x goes off to positive infinity, h of x goes off to positive infinity. So as x gets larger, y is getting larger. That's up behavior. And as x gets smaller, okay, h of x is getting smaller. That's our down behavior. Remember, this represents the left-hand side of our graph, and this represents the right-hand side of our graph. Okay, so hopefully those examples can help you get through these exercises. If you have any questions, email me, and certainly we will review all of this when we get back in class.